Good morning. Hey everyone, I wanted to go ahead and make this video because I've had a lot of people ask me about the QA-ES3 ESU jigs that I have posted on another video, and a lot of people want to know how to make them. Well, it's a process. So in order for me to make the QA-ES3 jigs, it takes a couple different things. One of the major things is I made these blocks, and I just CNC'd these on this device back here yesterday, and they're a perfect match pair, and they will clamshell together in the very end to make one plug like this one. This is the plug I started with. This guy here is made from high density plastic, which is found in cutting boards, and in between is where my wires are routed to each of their own separate pins. Right, so there's no wire shorting whatsoever in the plug itself. All the magic is done on the female side, which you can see the plug has the male side. The female side, which is attached to your different jig connectors, like this guy here. So I'm going to make some improvements on my original design, and this time here I've done a proper pin out, you know, to show everybody step by step how this is going to be done. And I'm going to include a link to a Google Drive that's got all the files, you know, including the CNC files to make these. I would like to see somebody possibly make a better version of this with a 3D printer, because one of the things that I've always kind of missed is this one here is too shallow, and there's not too much space to grip. I mean, there's a lot of tension on these pins when it's plugged into the QA-ES3. So in order to unplug this guy, it takes quite a bit of grip, which there's not enough real estate here to get a good finger hold. So I made this one here. I made it out of some of these chunks of tree that I have floating around my shop. And the reason that you guys probably seen that I've got chunks of tree floating around is because they have to slowly dry out. It's just the way it is. And so my shop over the winter time has been a very good spot for these to dry out. And I can make cool little things like this. It's the moisture content's extremely low in this piece that I used, and it machined beautifully, absolutely beautifully. You can see from my own reference, I have the numbers written out, and then this is the lid. I'm going to change this design probably a little bit, but we're going to see how well this works. So anyway, this is going to be this. You can see I didn't need to make it so big. You know, real estate's everything on the front of an analyzer. And also, you know, it's nice to make it look probably a little more professional. This really does look like two pieces of plastic kind of glued together, but it works. And, you know, as long as it works, nobody's really complaining. So I'm trying to come up with a more formal design, and that's why I come out with this one here. So this is the piece that I'm trying to get to, okay? Using the new design with blocks of wood, which if I had some high density plastic, I would have made it out of that, but I don't have it. So it is what it is. So there's that. My jigs that I'm going to be making, I have this one here, which is a Db9 female with a dual pad test patient return and a monopolar. But take a notice here, I have a 5-watt 15 ohm resistor in series. So we'll go over that. I'll show you guys the pinouts in just a moment and how I got to what I'm going to be doing. But this is one of the cables we're making. So the whole concept of this thing is to have your jig, this guy here, and it's going to be attached to your analyzer. So when you want to do different tests, all you have to do is connect, you know, whatever jig you need, and the pinout is magically done here instead of in the front of your analyzer using a whole bunch of different banana plugs, which is absolutely ridiculous. So I've had my guys using this particular setup for a period of time now, and it seems to be working out really well for them. They're able to do their tests very quickly, And this is just a video response because I've had so many people ask me, how do I make these? What's the pinout? So I'm going to give you guys the pinout, my pinout. And according to, you know, what you wire pin 1, pin 2, pin 3, all the way to pin 9, that's going to change your pinout on your female side. So try and do it exactly my way, or if you want to do it your own way, just make sure that you have consistency, because certain pins are going to be shorted together and certain ones are going to have resistors. So let's go over that right now with the pinouts. Actually, let's go over the bipolar, because this is a big one. This is a big change. The bipolar is going to be way better than my design. Let's see, that would be this one. Okay, so I knew that bipolar had a third pin, and we almost never see this third pin on a bipolar. So what I did is I took a bipolar plug, I drilled it, and I put a spring steel pin in there, which you can see I have it routed down the throat, down into my wiring harness to some pins. Well, I always knew that this could be done better. So I think I have finally found what I have been looking for. Guys, this right here is an Aquamantes plug, and it is a bipolar plug with the third pin. It is everything that I've been waiting for, and you know, without me having to modify it, which is very cool. It's a completely molded solution. You just have to find an Aquamantes handpiece, and then you can make this jig. All right, so bipolar, this is going to be a big one for bipolar, because the problem with bipolars is often people don't have the foot control attached to the ESU, and the third pin right here, that third pin is going to activate the ESU using the QA-ES3 analyzer. Okay, so the analyzer has the capability of using one of its internal switches to boop, turn on your bipolar. No need to find a foot control, attach the foot control, you know, all that jazz. All you have to do is plug this guy into the front of your bipolar, you know, and plug it into your Db9 male connector, and you're ready to rock and roll. So this is a huge change, and I'm kind of excited to get this guy up and going, because mine, it works. I mean, it's got all the proper strain relief and everything. It's just, you know, when you know that you can do something better, it always just kind of rubs you raw. So I always knew that I could make this one better than what it currently is, and I just needed to find that extra little piece. So when I found this kind of encouraged this whole video series right here that I'm going to do. Is this is going to be my plus one. It's going to do it better than what I had originally designed. So let's check out the pinouts, because this time I actually did it right. I sat down here with my multimeter, and I went step by step and verified every single pin, and which ones were shorted, which ones were not shorted, and stuff like that. So here we go. Let's turn you guys down to the desk. And all these files, by the way, all of these files are going to be available on a share drive. I'm going to give you guys the link. I'll eventually put it in the description down below. You can see all my work to do the pinouts, and it comes down to something as simple as this. How about that? All right, so for the adapter, this guy right here, the way that I did the pinout is with the pins pointing away from you, okay? So that's why it says the backside, because this is how you're looking at the QA-ES3. So this would be pin 1, pin 2, 3, 4, 5, 6, 7, 8. And you can see in the image, that's how I described it here. With those, with that orientation of those banana plugs, now you can tell, based on the male connector, what pin goes to what. It's based on the color code. I figured that was probably the easiest way to do it, instead of drawing stupid lines and stuff all over the place. So like pin 1 goes to Db9 male, pin 5, pin 2 goes to Db9 pin 7, etc. All the way down the chart based on the color. Right. I hope that focuses. That seems to be the easiest way that I could describe how to make this. All right. So that piece is set. let's go over the bipolar, the one piece that I was telling you guys about. All right. So this gets no simpler than what you see. We have the Db9 female plug and the Aquamantes plug that I just described to you. You can see that I have this pin here goes to pin 1 and 9. So pin 1 and 9 are shorted together, and then they're soldered to this wire here. This one here is pin 5, and this one here goes to pin 3. All right. So that's all going to be done down here, down the cable. I don't know. We'll see my Db9 cables. Maybe I'll just make this guy short so that the Db9 cable is the long one. We're going to figure that out in just a minute. I'm going to do that all live for you guys right here because it's a little bit of a process, and I want you guys to see how I make wiring jigs. It's taken me years to develop a really good technique. So we have Db9 female plug to the monopolar, and you can see over here that I have the 15 ohm resistor, and the only thing I didn't put in there is that it's a 1 watt or a 5 watt resistor. I myself have a 5 watt, and you can see right here that I've got pin 3 and pin 9 on the pin that's spaced out, which, oh yeah, come here. Okay, so you can see the symmetry of the plug. So the pin that's spaced out has pin 3 and pin 9 of the Db9. The next pin has pin 7, and the last pin has pin 5. All right. So I'm going to show you guys how to find those pins. We're going to do continuity and all that. It's actually going to go pretty quick. All right. I guess at this point I should probably turn on my soldering iron and prep it because it's going to need to warm up. All right, guys. So we're going to start out, and we are going to make the connector. And this is going to be really interesting. I'm trying to make it look way more professional than I did before. So let's take a look at what I got for my connector. All right, guys. On Amazon, I bought this 24-pack of banana plugs. These are really cool if you want to make your own jigs, or if you want to repair jigs. They're gold-plated. They're very durable. There's 2 securing screws. So the top securing screw is usually held for the insulation of the wire. The bottom one is actually the securing screw for the conductor itself. All right. So that's why there's 2 on there. There's actually a sleeve that we unscrew to get to the inner banana plug. Oh yeah. So you can see I just spin it out, and all that I'm concerned about is this inner piece. The outer sleeve doesn't even matter for what we're going to be doing. You're going to need 8 of those. The interesting thing is that they come with this cool little flat blade screwdriver. I've removed all the upper pins, which is the pin at the very back. See that? The hold down screw. I've removed all of those. We're not going to need them. I'm actually going to use that hole to thread my conductor in, and we're going to secure it with the bottom one. Let's move those over. And that means I'm going to be working from the back. So we're going to secure the wire. It's going to get placed into the plug like this. And this is going to be my trace for all my wires exiting the plug. Now, this is the first time I've ever done this, so we will see if I have to machine this out for where the insulation is going to be held down. That's what this little tiny hole is down here. I was hoping that I could put a tie wrap around it or something, and then when you clamshell it together, that would secure the insulation and, you know, be a strain relief on the rest of the cable. We're going to find out, you know, together, I guess. I was going to record this video before and then follow through with this later and answer some questions, but I figure I can probably do this all live, and, you know, if there's any questions or anything, or if I'm missing something major, hopefully somebody will bring it up. That would be great. All right, so some of the stuff that we are going to need in order to make this stuff happen. I have here a dual electrode. Notice that I'm using a squared off connector, which is not my favorite. It's because I didn't have enough time to get the rounded connector. You see the rounded one right here? This is compatible with more machines, like the plasma ESU, plasma coagulator. It takes the oval shape instead of the squared off shape. But if that ever becomes an issue, I can clip it later and put this guy in its place. That's no problem. This will just get us up and get going. And all that we're going to need from this guy is probably, I don't know, probably about a foot, I think. All right, let's see. What do we have? All right, get some of my fancy wire strippers out. All right, well, I'm going to make this guy a little bit long and clip it. The rest of the pad, it's pretty much garbage. The next thing we have to prep is our monopolar. Okay, so here is a fresh monopolar straight out of the package. This one, I think I also need about 1.5 feet. If anything, we'll shorten it later. The rest of the pencil is garbage. All right. Oh, yep. I have you guys probably recognize this. This is for a defibrillator. I also was going to make a set of test jacks with it to work with our defib analyzer. So that's why that guy's in the box. So what we need now is some Db9 connectors, some good ones, because you use garbage quality like this guy here. I mean, take a look at the size difference of those cables. Now, not all Db9 cables have 9 conductors in them, or 10, because it's also got shielding, which is the outside. A lot of them, if you cut them open, you're going to find that they only have 4, maybe 5 conductors, sometimes only 2 different wires inside. So not all cables are created equal. I'm sure you guys are well aware of that. But as I started cutting open serial cables, I found that many of them don't have anything connected to most of these pins. That would be a no-go. All right. So one of the things that I'm going to start out with this build is to find some really robust cables. And I think that this is going to be an excellent cable for that. Not very long though. So that's why I'm thinking that this guy should be for my adapter plug. Really robust dingle hopper off the ESU analyzer. I think it's going to be nice. Okay, so let's see. How long should I make it? I'm thinking about that long. So from the top of all this to down here, that's about right. Now, guys, there is a reason why I'm going with the male side pins on the ESU analyzer, okay? The female side is going to be on the side of the ESU itself, because when it energizes, you don't want energy to be exposed, because if you just happen to put your finger over the end, you could zap the hell out of yourself. But if you end up using the female side of the plug, if it dispenses energy on those pins, there's no way of you touching those pins, okay? So the ESU side is going to get the female, the analyzer side gets the male, okay? So let's put that guy back. Let's measure this guy out again. Not that long. And cut. All right, that's a hefty little cord there. This would be probably a pretty good opportunity for me to get my mat back out. I'm still rebuilding my desk from one of those last videos that I did. All right. There we go. Now I can lay out all my stuff and at least make this look semi-professional, I guess. All right. So this cable here is just going to sit off to the side. It was for demonstration purposes because of the gauge of the cable. I might use it later. We'll figure that out. All right, so I got this guy. What I need to do is I need to strip it back Oh yeah, I'm definitely going to have to do some modifications on this case. That's going to be really tight. Oh well, practice makes perfect, guys. So I'm thinking right about there. I strip it to right about here. And yes, I am using the wrong type of strippers for this. Okay. You see how I did that? You guys will develop these techniques yourself. So I stand them up and I rotate the cable around, which scores the outside. Give it just a tiny little bit of a grip and it comes through for you. All right. So this outer sheathing right here, this is going to be some of your ground for signal grounding. We're not going to use that. Oh, this is lovely. Guys, I don't think I can use this cable. Oh, let's see. Let's see how many conductors are inside there. I do not think that that's enough conductors. All right, let's see. I've got 2 wires on this side. Well, that just goes to show you, you never know what's inside these cables. Now, they're beastie cables. Those are beastie. Look at them. All right. Not looking good for this cable. If it wasn't so short, maybe I could use it for bipolar or something that only requires a couple pins. All right, so I got 4 conductors with some ground. So technically 5 conductors. Garbage. So when I made my initial jigs, I went through probably like a dozen cables to get to what I had. I am not kidding. I went through quite a bit. So I brought, a couple extras just in case. You never know. Oh, that's such a disappointment too, because that was such a hefty cable. Would have made for a really durable jig. Let's see. The outside. Let's cut it right here. This one feels like it's proper. All right. A little bit more. How about right about there? Here we go. You guys see how well that technique works. Woo. This one already looks really nice. Check out that shielding. It's like a micro braid. Should have known. This is a McKay cable. Yep, this is the one I need. All right, so this shielding, I'm gonna probably just roll it down, because what I'd like to do is when I clamp down, I'd like to clamp down on the shielding and on the outer sheath. So that means I'll probably have to sand this out a little bit, sand it out on the other side. All right, what do we got? Oh man, this is also a really nice cable, but I don't think it's got enough conductors. I got 1, 2, 3, 4, 5, 6, 7. 7 conductors. Oh, check that. All right. McKay. There are some tiny, tiny wires that are located inside this inner shielding. So you see there's two separate inner shieldings, and in those are going to be 4 more wires. Yep. Wow. This is probably a very expensive cable, I bet you. All right. Well, one thing's for sure, the gauge of these wires is way too small for handling ESU energy, but there's some other pins that we use for shorting, which is for triggering, and I might be able to use it for those. Wow. Okay. Let's see. Let me get my chart so that I know if this cable is going to work. I'll be so upset if it doesn't. Be cutting all my cables in half just to figure out what the pinout is inside them. All right, so I got pin 1, pin 9, pin 5, pin 3. Just to make this easy, I have my old cables here. Just going to connect them together real quick so I can do a continuity check to make sure that my energy carrying pins aren't going to be on the thin wires. If they are, this cable's done. I can't use it. Bjorn, how are you doing, sir? Technically, I need 6 conductors, but a bunch of the other ones are not used. So yes, I could move some around, which would mean I'd have to redo my pin out. The front of the analyzer has 8 pins, and based on the test, you are going to utilize 8 different wires. So some of them are not going to be used hardly ever, if at all. And I don't know, maybe I could change my pin out and modify those. All right, let's see. So in order to do this, I set my multimeter on continuity mode. I've had a lot of people ask me about why I always talk about continuity mode, because we use it all the time. That's really how simple it is. We use continuity more than I think almost anything else. All right, so I'm going to check the first pin, connect it to my lead, and from there, okay, from there, all I got to do is go through my conductors and figure out which one it is. Okay. Oh man, that's disheartening. that is one of the tiniest wires. Okay, so the one that I'm registering here, monopolar. Oh, geez. That's going to be an essential pin. So this cable's garbage, at least at the moment. All right. Third time's a charm, I hope. Either that, or I'll have to stop this video and go find some more serial cables. That's not cool. All right, one last one. Let's see how this guy fares. This is a reasonably hefty cable. I have some hope. None of these cables are like the best of quality. If I was making these jigs, I would probably take the effort to go out and purchase like nice high quality cables. Oh wow, yeah, this one has quite a few conductors in it. Looks like I got a winner. Let's try this guy. There we are. I don't know where I got this cable, but it looks like a proper one because we have a selection of different wires. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. One cable. All right. Well, at least from this one cable, I will be able to make for you guys 2 jigs. So I'm thinking monopolar. No, we're going to do bipolar. We'll do a bipolar jig and the adapter. We should be square. So all I'm doing now is just getting rid of some of the extra insulation. All right. Bonus. There we go. There we go. Hope you guys don't mind the noise. I love having battery-powered vacuums, and I hate getting metal slivers in my hands. All right, so I got my cable. It's the male side. We got our jig. We are ready to start doing this. Got my 8 different banana plugs. So one of the first things I'm going to do is I'm going to strip back the probably about a ½ centimeter from the end of every connector. All right. Boy, these strippers are not doing so well. Okay, and while I'm at it, I'm going to go ahead and tin these wires really quick, because nobody likes fighting conductors that are going down into a hole. When they spit off and they, don't want to go down, they fray. That's such a pain in the butt, so I'm not going to do that. You guys will see that I actually tin wires really quickly. All right, let's turn this guy on. That should be about enough. I just turned it on and it's already up to temperature. Man, I'll tell you guys what, I do like this quick, this what, a TS1200. Such a nice system there. And also, while I'm tinning it, kind of helps get rid of some of that extra insulation that's sitting right there. It didn't strip it as clean as I'd like it. There we go. You see, I just splashed some of my stuff. I could have cleaned my tip. If I get extra, I'll just splash on the mat, because with this being silicone, it's easy to clean up. There we go. All right, and just like that, they're all tinned. We're good. Next step. Now we have to do a continuity check between the wire and the pin, and based on my pinout, which is this guy right here. So like the adapter pin 1, which is going to be this guy right here, is going to go to pin 5. So what I have to do is connect to pin 5 and run through them all real quick and see which one's going to hit positive. There we go. I know this isn't exactly conventional for how some of y'all do business, but it is for me. Okay, green. All right, you seen how when I was going around, I checked all of them, even though I hit one positive. You want to make sure that they're not shorted someplace else, like up inside the connector. Serial cables are the weirdest cables in the world. They do all sorts of stuff based on whether or not it's a null modem, if it's a regular Db9 cable. So always check all your wires just to be sure. So this one's going to go to green. So as I said, I've got a upper hole. I will shove the wire in the upper hole, and then it's going to curve. So I'm going to fold this wire down just like that. It's going to go in the upper hole, curve, and go down to the securing screw in the bottom, and I will just screw it down. This is part of the process that I'm going to have to get real straightened out because I don't know how well this is going to work with securing screws. I normally solder these wires straight in to the banana plugs. Shoot, that worked. Okay. So let's see, pin 1, check. All right, so pin 1 goes to pin 5. All right, and let's see, I got pin 2 goes to pin 7, 6, 7. Okay, looks like the pin 2 on my adapter is going to be purple. Normally I'd use needles and click my my lead on needles, so that's why I'm being extra cautious, because it could, the gator clip could touch 2 wires at the same time. Nope, looks like we're good. All right. So just the same, goes in and down. Oh, shit, that didn't work out so well. Maybe I will solder these wires right into each banana plug. It just seems like it'd be a better connection. Alright. I know, guys, this is going to be way boring, but this is the process, man. This is absolutely the process for doing this type of stuff. There we go. Okay. Now we'll place that one here, pin 2. So notice how I'm getting the wires to go towards the middle. That is going to be because in the middle is where the wire trace is going to be. All right. Here, and I'll show you. Let's see, pin 1, this one, pin 2 is this one. And you can see right there, that's how the wires are going to run, right down the middle. And shoot, I didn't strip it back enough. Okay. All right, all right. There we go. There we go. All right, much better. So green's pin 1, purple's pin 2. Now the color code's not going to be the same on your cable. That's almost a promise, because like I said, these are the most unstandardized cables that you'll find out there in the world, is serial cables or Db9 cables. So just because I say that my pin 1 is green does not mean that yours is green. That's a promise. Okay, there's one. Okay, so what I have to do is I have to feed it in through the side. And then I have to put it in its place with the flat blade screwdriver before I tighten it down. I gotta check this guy. All right, let's see. Pin 2. Purple. So before you get it all together, make sure you have continuity. Like right now, I have a little bit of doubt on whether or not I've got some continuity, so I have to go back in and check it. That's pin 2, which pin 2 goes to pin 7. There we go. Okay, so I have continuity. It's good. Because once you get it all together, there's no going back. So might as well check it right now if you have any doubts. Let me clear some stuff out. Okay, pin 1, pin 2. Let's see, pin 3 goes to pin 9. So pin 9. All right, pin 9. Okay, pin 9 is black for my cable. All right. All right. Now let's go ahead and start placing these in their spots. green, pin 2 purple, pin 3 black. There we go. And that should bring this cable right down perfectly to where it needs to be. Okay. I'll have to, shorten up some of these wires when I'm in there. All right, let's continue on. Let's see. Pin 4 needs to go to pin 4. Well, that one's easy. And there is, if you guys didn't know, there's numbering on the inside of the connector. You can see it. So pin 1, pin 2, pin 3, pin 4. And looks like it's orange. Okay, so here is a situation. I have 2 different cables that are ringing, so I have to check my connection. Okay, it is orange. My gator was touching more than one point. Okay, orange. Give me another one. I should play some music or something in the background. Guys, I wonder if that would get me hit on the whole YouTube algorithm. Okay. So pin 4 is 4. And these guys will get inserted like pretty far down into this piece. Now these pins here are 25 millimeter on center, so it's a real easy jig to make if anybody wanted to make a jig with a 3D printer. 25 by 25, and it's 8 pins. Okay, so let's see. Pin 5 goes to pin 3. Let's see. Pin 1, pin 2, pin 3. Oh, this guy wants to jump all over the place. All right, there we go. Adapter pin 5 goes to this guy, pin 3. 1, 2, 3. Come on. 1, 2, 3, 4, 5. Okay. I don't know how that went wrong, but I'll move it because at this point, who cares? Okay. So that's pin 3 on the Db9. Let's try pin 4 again. Apparently, my gator clip was shorting a couple different ones out. Yellow. Okay. All right. Yellow it is. Okay. Through the upper hole and down right there. Oh, that's such garbage. My inner technician wants to solder these wires. All right. That's not very good. That wire's going to yank. All right, let's see. All right. I got to steal a pin from another one. So what happened is the gauge of the wire is so small that the set screw went all the way in and it fell on the inside. So now I have to use a second set screw to press on the first one just to get a good contact. Like that. Shoot, that's not going to work. All right, guys. It's time to do what I said I was going to do. I'm going to start soldering wires. All right, let's do this. Okay. No more goofing around. Come on. There we go. Geez, I think that actually worked. All right, let's do a continuity check. We're good. All right. Now the pin's just going to be hot as hell for a little bit. Yeah, like that. Jeez. I know, guys. I need to have a better workspace. Okay. There we go. Use this to press them in. Okay, so let's see. I got pin 1, pin 2, pin 3, pin 4, pin 5, pin 6 goes to pin 1. Yep. Uh-oh. Okay. that had me worried there for a little bit. I went through all the pins and I got no response. All right, looks like that one's brown. All right, pin 6, the brown. There we go. So what I really need to find is a serial cable or a Db9 based cable that has larger wires in it, basically larger gauge, because that would solve a lot of these problems that I'm having right here. Okay, 1, 2, 3, 4, 5, 6. Yep. Okay, and let's see. I got extras. It's nice. That's a nice feeling. Okay, so the last pins, I got pin 7 on the adapter goes to pin 6 on this guy. So let's hop on down to pin 6. Blue. All right. Okay, pin 7. I think you guys are seeing some of my problems is I did not shorten my cables up enough. And so now I got to worry about a wire tuck. Okay. Just like that. So the black, I know to change the design and make this gap in between the pins a wee bit larger. That way there I have more space to tuck wires in this little tiny gap. There's plenty of real estate in here. So I'm going to modify that file before I release it to everybody. Okay. Now I got the orange. And the brown. You can see what I'm doing is I'm using my screwdriver to get down there, pull these wires as far up as I can. There we go. Well, it looks like chaos. It's not. I like to think I know what I'm doing. Okay. This blue wire here, this guy's gonna have to get shortened. No, jeez, that's a long ass wire. All right, come on, you. All right. Let's shorten him to here. If I make another one of these jigs, I'll actually get a proper set of wires that I purchase off a common place like Amazon, and I will get the proper pin out for that exact cable with that color wire. So you guys won't have to do continuity checks and stuff like that. But I mean, based on whatever country you're in, I have no idea where Fluke sells their analyzers. We'll just be safe and say you should do a continuity check on all your wires, just because. Wow, that's a short little wire now. Okay. There we go. Much better, much better. Okay, and now for the last pin. Last one is pin 8 to pin 8. Doesn't get easier than that, huh? Pin 8. Oh, shoot. My meter went to sleep. All right. Gray. Okay, great. So same thing. I got to clip it, retin it, strip it. This is not the proper stripper for these. Okay, and let's see the last banana plug. Here we go. All right. And that is pin 8. So pin 9, which is the red wire, does not do anything. It is absolutely useless. Okay, so the only thing I can see I have to modify is I have to make this strain relief area a little bit wider. And let's see, how can I do that real quick? Yeah. Can always do that with a Dremel, right? Oh yes. Dremel's got these special side cutting bits. Okay, let's do this. So what I'm going to do is I'm going to enlarge the gap a little bit. There we go. Doesn't take much. All right. So mind you guys, this is only my second draft ever of making these jigs. So I will make a better revision where this track is going to be wider. And I won't have a lot of these problems ever again. That's a promise. Okay, this red wire right here, I'm going to clip it off. It is absolutely useless. And look at that. Man, it fits nice. Cable just sits perfectly in there. Okay, now I can get rid of some of this garbage. All right, and now I'm going to use my flat blade to tuck the wires properly into their channels because I want this to clamshell together perfectly. In order to do that, these wires got to go somewhere, man. There we go. like it. That looks good. All right. Now, I think I really like that. I dig it. So what happens is this guy here is going to fit on, and it's going to clamshell all the way down. What I want to do is I want to shoot some hot glue down in here. And I think before I finalize it like that, I should do one last continuity check just to be sure, because once you glue this guy together, it is not going to come back apart very easily. I'll probably have to machine a whole nother one. So that would suck. But let's do it. Get one of my probes. I guess I can move this guy out of the way now. Okay. Clip this guy on here. All right, let's run down through it. Db9 pin 5. That's 1, 2, 3, 4, 5. That's this guy right here. This one here should go to pin 1, which is this one. And I should not get any others. We're good. Okay, pin 2 should go to pin 7. 1, 2, 3, 4, 5, 6, 7. Just to be sure. Okay, pin 2 goes to pin 7. Yes, we're looking good. Okay, pin 3 goes to pin 9. So let's find pin 9. Let's get right over here. Pin 3. All right. All right. Pin 4 goes to pin 4. Okay. Hold on. I think I'm touching more than one pin here. I am. There we go. Okay, pin 4 to pin 4. Excellent. It's looking good. All right, pin 3. 2, 3, which is this guy right here. So I got pin 5, which is this one. 1, 2, 3, 4, 5. Goes to pin 3. Okay, we're good. Pin 1, which is this one right here. Should go to pin 6. 1, 2, 3, 4, 5, 6. Excellent. Okay. Pin 7 of this guy goes to pin 6 of this guy. All right. And the last one is pin 8 to pin 8. Guys, I love it. Okay, so it is ready to get glued. Make sure one last time that none of these wires popped out. I want to make sure that this guy glues down nice and even. That's looking really good. Okay, so in order to make this work, I'm going to need, let's try a dead blowed hammer, and let's see, how much space do I need? I'm going to need some wooden blocks. Okay, so the object is I'm going to place this guy right here down the middle and pop it and seat it properly. So in order to glue this guy down, I'm going to use my infamous glue gun. The reason that I like using this glue gun is because unlike Elmer's glue and a lot of other things that might conduct electricity even in minute amounts, this type of glue does not. and I can properly seal these wire channels down here really nicely. All my pins are square. That's the beauty of CNC machining. You don't have to worry about the drill press or whatever not making a perfect 90-degree hole. This is looking so nice. It's going to go together really well. This version 2.0 is a much nicer block. And I get this material for free because I just get it from old trees. I machine it myself. I've got my own bandsaw and everything. And then once I get my raw material, pop it over on the CNC, cut it out. I cut out the top, cut out the bottom, and it's good to go. I really think I'll stick with this design, seating them in the back with the wire channel. All I need to do is make the wire channel a little bit larger in diameter. Here we go. Here we go. So one of the other nice things about silicone mat is that the silicone does not stick to glue. So that's a pretty big plus. All right, let's do this. I'm going to start up here, shooting it into the channel. All right, that is looking excellent. Let's see, top to top. All right, yep. Place my block on and see it. That's probably loud as hell on you guys' speakers, isn't it? Sorry about that. All right, well, good enough for government work, at least for number 2. I would like to use a hydraulic press to put these together, but it's looking really good. My banana plugs are in the right spot. They came through perfectly. The wood didn't split. There's just a tiny little seam around here. Oh well, I can live with that. So this is version 2.0. That is what it is, guys. So that's going to work out quite nicely. Let's take a look at my original. So you see my first prototype where I actually had fasteners, and this one here uses hot glue. What I should have done is I should have used my hot air station over here and heated up the whole entire block, so that instead of cooling the glue as soon as it touches, it actually keeps it hot, and I should then get it to squish out. But at least all my wires and my wire channels are secure. I mean, look at that. Except for that little tiny hole around the side. This block here looks actually pretty good versus this one. All right. So that's that one. Oh man, I'm abusing my coffee here. And let's see, the last thing that I need to do. All right, I can unplug this guy. So for the last one, which is going to be my bipolar, I'm going to use the same cable that I started out with, which, let's see, where is that bad boy? I've got all my solder, my jumper cables. So this guy's done. Next, it's going to be this guy. This one should be much simpler. The reason that I have to work on this guy today instead of the monopolar is because I forgot to bring some resistors home with me. So I need a 15 ohm resistor. Actually, it could be a 5 or 10 ohm, but 15 is the number that I go with because of how the ESU devices and the analyzer work. 15 ohms, 5 watt. That's for this guy right here. I didn't bring it with me, so we're going to do bipolar. That is this guy right here. Now what I'm going to try and do is keep this cord as short as possible. And hey you, what you doing? I guess I have a guest here helping me out. Okay, so this guy here, I'm going to keep it as short as possible. That way there I can shrink tube the rest. So let's go ahead and clip it. How about right about there? Use this stripper, strip it back. All right, we have 3 conductors inside, and they have a nice nylon coating on them. This is actually a very nice connector. I'm glad I found it. All right, and let's see, where's our Db9 female from the last wire cut? Not this one. This one. All right, so I'm going to make this one here probably about a meter long. That way there you don't have to have your analyzer sitting right up on it. Let's see. Wow, about that long. Yeah, we'll do it a little bit longer. Oh, right there. If the cables get too long, then it gets to be a burden when you're in the field because they want to get tangled on each other. All right. So let's start out with this guy. How about right there? If you guys have never used this style wire stripper, for this diameter and smaller is the best that you can get, I think. Let's strip back all that grounding. Okay. Now what I'm going to do is I'm only using a couple different pins, right? And I could use the wiring chart that I just made from making the adapter, since it's the other end of the cable. But I'm showing you guys that you should always be checking every single cable that you're goofing around with. So I'm going to do it from scratch using only the pins that I say we connect to. So we got pin 3, pin 5, 1, and 9. So on the female side, it's reversed. So pin 5 is up here at this corner, pin 1's over here. So let's see, pin 1 and pin 9 are shorted together. So let's find those two first. Hold on, guys. I'm losing my mind. Okay. See, I'm using a precision screwdriver to shove it in the pinhole. Doesn't really matter. Okay. And now what I'm going to do is find which one's pin 1. Oh, geez, there's no way I did that on the first check, right? That doesn't happen. So all I'm doing is touching the ends of the wires, being sure that I don't have any other alerts. Brown. First wire. Lucky. Okay, let's try it. Okay, so 1 and 9. So let's go to pin 9. That's this one right here. Looks like it's black. So brown and black on my cable. Okay. So brown and black are going to be shorted together. don't strip back very much. And here is where we are going to prep this thing for its final sheath, which is going to be this guy. Before I obviously start doing anything else, I'm going to put a large black outer. So in the end, this one is going to slide almost all the way up over this. I'm going to leave it about that far to sit there and dingle hopper, because if I were to put the sheathing all the way up to the very end point, if I put the shrink tube all the way up, then that is the weak point right there. So I'm going to try and prevent that by leaving, you know, let's say an inch to a half an inch for it to weeble wobble. You see that? So instead of putting one tiny little strain relief, it's going to have all this to be a strain relief. And it'll be just like that. So let's shut that bad boy down. And now we have to figure out which wire goes to what on this side. We got red, blue, and white. All right, guys, I'm going to go ahead and tin these guys up. Now, this is going to be the same on your Aquamantes handpiece, obviously. So whatever pinout I figure out here, that's what you guys are going to have too. Okay, I don't know if you guys can see that. When I put solder on, you see how I leave a bulb of solder at the end? And I've said this in several videos, how when I'm applying solder, I'll put some on and I'll slowly pull my iron away and it leaves a little tang of solder sitting there. The reason I do that is because when I match wires up, it goes perfectly flawlessly. And the reason it's going to do that is because you have extra solder there. I don't have to feed more solder in with this hand. You know, I can just line the two wires up and touch them. It's going to be very easy. All right, and let's do some small black inner. These guys. I'm just going to cut him in half. There's 1, 2, 3. So the two wires I said go together, black and brown on my wire, on my cable. I'm going to twist them. And then I'm going to go ahead and put I'm going to tin them together. Just like this. Probably should have. All right. I should have went ahead and stripped those back a little bit further, but okay, same thing. You can see that I left a little extra solder on there. So here's where I slide my sleeve down, just like that. And pin 1, pin 9 go to this guy right here. So I'm going to switch this dude over. It's white. Okay. So I'm going to connect the white wire to this two wires right here and hold it there for a second. So you can see, oh, maybe you can't see. The reason I put extra solder on there is because now I don't have to feed solder into the wires. It's already there. And it's that easy, guys. That easy. Right, and since I have my hot air station here, yeah, my lights are gonna flicker. Ooh, Guys, I hope you all have a hot air station at your hospital or at your workbench, because it just makes life so much easier. And they're not that expensive, just a couple $100, man. This is dual layer shrink tubes. What I'm doing is I'm heating it up an extra amount to make that glue come out. And that glue is going to really help the bond. All right, so there's that one. So we just did this pin right here. Next, we're going to do the little pin, the little stubby. Let's figure out which one that is. So let's put one on there. Blue. Okay, so the little blue guy. And that one, according to the chart, connects to pin 5. So I'm going to move my screwdriver over to pin 5, which is that one. And let's test for continuity, figure out which pin it is. It's green. Okay. Just to be sure. So you can see what I'm doing is I hold the green out of the way while I check them all again, just to be sure. It's all about double checks, triple checks, whatever you got to do, man. I've made enough mistakes throughout my career that I know to measure 3 times and cut once, you know. Okay, same thing with him. Let's tin him up. All right. All right, blue. Let's move it so that y'all can see how I do this. So what I'm going to do is bend the wire so it conforms to the general direction of the wire below it. You can see I'm using my pinky to line them up. This is just the way that I do it. There we go. And you can see this technique works kind of well for me. And again with the hot air station, because I don't want solder joints touching other solder joints, that's why I stop and I heat up the shrink tube and then I proceed to the next one. Some people will do the heat shrink tube all at one time, and you would think that saves time, but when you get a bridge between connections on accident, you're gonna regret it. So obviously the red wire is the last pin. So let's see, the last pin here is pin 3. So I'm going to move my thing over to pin 3. 1, 2, 3. And let's figure out which wire that is. Okay. Looks like it's orange. Right, it is. Okay, so that is going to be the last wire that I'm going to use. So I'm going to go ahead and clip off all these other wires. And here's a trick, guys. Don't clip them off straight. Clip them off at an angle. All right, and make that angle really extreme, because that way there they don't all terminate at the same exact spot. Because you don't want a whole bunch of conductors touching or near, being terminated, because they might, just by chance touch each other. So by clipping them at an angle like that, they're all at different lengths. So even when you glue them together, they'll never touch. All right. So no, I didn't clip them off flush. They're absolutely fine the way that they're at. Strip this bad boy back. Tin it real quick. then we're going to put on our last heat shrink tube, which is right here. Okay, same technique. Oh, shoot. Here, let me turn it so y'all can see. Same technique. I'm going to hold the wires close to each other and then use my pinky to line them up. And what it will do is it melts those two solder bulbs together. And as it melts those two solder bulbs together, the wires just naturally pull together, and we're good. All right. Put this guy there. So here's the trick to make this look like a much better finished product. We're going to go ahead and give the wires a twist like that when we slide up the shrink tube. Okay. Just like this. I'm going to hold this guy here so that I can slide it. So you can see how I've got them in a twist. That just gives you a much better look when you shrink down your final tube. Just make sure, right there. I'm just going to hold it in place while I shrink it down on one side. There we go. And now I'm going to turn up my temperature. Let me move this guy over. Look at that. This hot air station does wonders, man. Right, that is looking like a pretty nice finished out cable. I got the glue squirting out at both sides, so now it's a watertight connection. Right, I can disconnect that guy. And now I have a proper bipolar connector to Db9 female. And this one here is going to work absolute wonders for me. I'm going to go ahead and disconnect this guy. There we go. Because we don't actually need the screw down pins. Actually, I prefer not to use the screw down pins because if you yank the wire on accident, I want it just to fall out of the male connector. So here we go. I'm going to let that cool in a straight position like that. Gives us a nice finished look. And like I said, you have a very soft right here dingle hopper that's going to allow you to have a pretty good strain relief. Whereas if I were to have moved this connection point up, now you'd have a smaller strain relief point, and that's when you get more internal wire malfunctions. So this is a pretty good version 2.0 of this cable. So guys, until I get my 5-watt resistor, it's going to be 2.0 of my block. It's a Db9 male and 2.0 bipolar with the auto pin, which is a very cool pin that allows it to automatically activate the bipolar on most Covidian, Valley Lab, those type of bipolar units. Anyway, guys, I'm gonna have to cut this off because I ran out of cables, and that is what I have. So that's how I make jigs. I know there's probably a simpler way of doing it. Somewhere, somebody's probably got a better way than me. But it's all about doing continuity checks with your multimeter, checking it before you seal it up. You know, I've made all these mistakes before throughout my career, and it's all about doing checks, doing rechecks, making sure that you got connection to every single one of your pins, and then sealing it up and giving you a nice professional finish. The only thing I wish I would have done differently is if I would have done this, I would have heated this up with my hot air station, like I said earlier, so that the glue didn't automatically harden, because that's what happened, is the glue starts hardening as soon as it touches the wooden block. Now, wood does not conduct heat very well, but when it does, it does like to cool things off pretty quickly. So that's a problem. I should have heated up the block before I put the glue on it, so when I squished it together, it wouldn't create this gap. But I'll tell you right now, this thing is going to be crazy durable. So take a look at that. So this is going to go in the Fluke QA ES3 electro safety analyzer. You pop this guy in the front, and then use different Db9 male cables on the other side to go ahead and give you your different pinouts based on your different functions, your different tests, right? Because I personally believe that doing the phone operator thing on the front of your analyzer is a bad decision. The one reason it's a very bad decision, not only because you can never remember what pin goes to what freaking cable, that's just ridiculous, but you don't want to wear and tear on the front of your analyzer. Guys, plugging and unplugging stuff throughout all of these tests, that's going to wear the hell out of those pins, and you're going to be repairing your safety analyzer for thousands of dollars. It doesn't make any sense. Whereas this guy, could you imagine just buying another adapter like this? I mean, if by chance you wear it out or something, you just buy another one, right? Or make another one, right? That's why I did the video. Anyway, guys, Hayden, thanks, man. I appreciate that. Thanks for watching, guys. Fundamental. Is that a tiny pup in the background? That is my fat bulldog, and she is right over there sitting next to the bicycle. She decided to come in and help me out. Dog just loves being next to me when I'm sitting here in this nice air-conditioned office. But Kavathan, thank you for tuning in, man. I appreciate this. Kyre, thank you, man. I appreciate that. Now, what I showed you guys here, this type of thing, yeah, it's only for one analyzer, but think about it this way, guys. Making these type of jigs applies for all sorts of different stuff, and I just wanted to show you guys my process for making a jig. Now, I already did the hard part. When I did these pinouts, I already did the experimentation with like a breadboard to figure out what circuit is going to make the machine do what I want it to do. I already did that part. So now all I had to do is come up with a better pinout so that I could share it with you guys, because before that was just chaos. I couldn't explain to you how I got it to do what I needed it to do. But these pinouts here are spot on, guys. And the thing is if you see the way I'm doing it, fundamental, I am using flux core wire, and because I'm using fresh connections, in other words, I'm clipping the wire and I'm stripping them immediately, then tinning them, I don't have to worry about oxidation. If you have a highly oxidized wire, yes, you have to use flux. but flux core wire works like a beaut. All right. So the trick is you tin both wires, you line them up next to each other, and you just run the iron long ways down the wire. Don't just put it in the middle and expect them to go together. Because of fluid dynamics, when you heat those two up, you drag the iron down the side, and what it does is it makes that bulb stretch out along the entire gap, and both wires are sealed together. Then you heat shrink it, and you move on to the next wire. So tin your wires before you try and join them. Works 100% better. I see guys sitting there and they got those like those grabby arms where they got the wires up and they're trying to tin it, trying to match them up. Guys, just tin your wires ahead of time. I use just one of these simple pan vices. Just stick the wires up, fray them out, and then just tin them. Go right down the line, tin them all. And when you clip them, like I said, don't clip them so that they're flush. You clip them so that they're at an angle, you know? So what happens is if you clip them at an angle, the wire tips are never going to be together, right? So, but if you clip them flush, all your wires potentially could touch, which I don't know what that's going to do for your analyzer, right? Maybe it thinks, hey, you have, you know, an illegitimate load on it or something. I don't know. But what I do know is you never generally want those wires to touch. So clip your wires at an angle. If you ever have to terminate a bunch of wires internally, clip them at an angle. And also tin your wires, man. I'm going to make all these files available. It's going to be, as soon as I edit this, it's going to take probably half a day for this to process because it's, what, an hour and 42 minutes long. I am so sorry that this took so long, guys. But if you're doing this on your own and you're not explaining it to people, trust me, you can get this done in like half hour, 30 minutes, you know, for just putting together a jig. But, you know, trying to explain it just drags things out. But anyway, I'm going to leave the description for my share drive down below so that you guys can nab these files. The pinouts, I'm gonna leave the raw files down there so that you guys can see those and you can use those pinouts to make your own jigs. Go ahead. You know, we're always trying to make ways to do business better, and this is just the way that I figured it out. So, DJ, what's up, man? It's about time you joined in. I did not announce this because I was just sitting inside and I was working on these pinouts, and I just finally finished them up, you know, making them look all nice and pretty and legible. And I decided, let's just do a live stream. I was going to record this and edit this and make this all just fantastic. But guys, I don't know. Live stream just seems to be the better way to do these type of things because it is a long drawn out process. And I just want you guys to see in real time some of the shortcomings that I run into. You know, like the wires being too long. I had to clip some of them down so that the shortest pins were shorter, longer. If I were to do this again, I would do it differently. I would trim those wires according to their length instead of tucking them all in the channel. But whatever. One more semester till you graduate. DJ, I'm telling you what, man. Oh, you're going to love this career field. And when you work for a different hospital than the one that I currently work for, certain stuff like this is going to help you out. My current hospital, they're about quantity, not quality when it comes to PMs. All right. It's so frustrating. It is not at all what I signed up for Biomed for, is to be just a PM pounder, you know, just to get numbers and not to give a shit about how well you do them. All right. Fundamental, what's my career field? I am a biomedical equipment technician, which means I fix medical equipment. If you haven't seen my other videos, check them out below, man. Check out the channel. I've got a couple hundred videos now about a variety of different things. Everything from medical lasers to, you know, general electronics, you name it, man. I've tried to cover it. So hopefully in the near future, I'm going to have some other stuff. Guys, also today's Sunday. For all you guys that are going to watch this video in the future, this week, MD Expo is going on in Dallas. I'm going to be up there. I'm driving up Thursday night. It's going to be a lot of fun. And if you guys are going to be up there, I would love to meet some of you guys. It's going to be a blast. And there's so many people already that I need to like get my calendar and write down like all the people that want to talk and stuff. So it's going to be very, very fun. DJ says you've been a big help, man. Thanks. If you have any questions about anything particularly, I would love to try it and cover it for you guys, because there is all sorts of stuff that I have plans, all these big plans, and I'm trying to get the stuff when I can. And also tomorrow's Monday, I have a new Biomed 1 that's working with me. Yes, my first Biomed 1 that I think I've ever worked with my entire career. And I'm going to be using that technician to help me figure out what type of stuff Biomed 1s need to know. So my content is gonna change a little bit. I've moved into a lot of technical stuff, but I need to get back to some of the basics, because it's clear to me that some of the Biomed 1s need a little extra help on some of the basics. We Biomeds need more easily accessible. Hayden Lewis, you are absolutely correct. And guess what? I am talking with several other biomedical equipment content creators, and hopefully I'm going to have these guys on a live stream very soon. Today was just a rush. I was going to let some of these guys know to, hey, tune in, because these guys have excellent channels too. And I've talked with several of them, and I would love for them to join me and maybe either do a monthly Zoom meeting where people can tune in, and between, the 3 or 4 of us, maybe we can help you guys out with some of your problems, some of your questions, and answer it live instead of like doing formal videos. We can answer something really quickly, and some people can answer stuff way better than I can. So if I can get these other content creators on board, a couple of them have said they'd love to do some work with me. This week, I'm going to be meeting with the College of Biomedical Equipment Technology. So I'm hoping to talk to some of those guys and see if they would like to set up a monthly thing where we get together on one day, maybe set aside a couple hours where we try and create an open forum for biomeds, because there's a lot of stuff that we see, some weird stuff throughout the month. And maybe we find some errors on some equipment that are easily addressable. I would love to find out what some other people, experience. So, can you make videos about repairing ultrasounds in the future? I would like to do that. I have been trained on several ultrasounds, the Siemens S2000 and the IE33 and IU22 from Philips. I've done ultrasounds before, not on this channel though. So I do specialize in computers. So ultrasounds, if you work on computers, that's a huge plus, trust me, because a lot of the problems that you have on ultrasounds are going to be like user database, working with PACS, getting your unit to talk to PACS, besides all the user abuse. Ultrasounds get a lot of user abuse. Let's see. DJ, I'll see you around, man. Thanks for tuning in. Hayden, I have been invited by a couple people to visit their booths and to sit in and talk with people. So I would love to set up my own booth. Imed, based out of Dallas, those are a great group of guys. They allowed me space in their booth to set up a bunch of stuff. I was thinking about doing it, but man, now after talking to more and more people, I'm going to be very busy. I don't know if I can sit in one booth. We'll find out. We're going to see. But anyway, I'm going to be wearing a shirt just like this up there in Dallas. So if you guys see me up there, just stop by and say hi, man. Let's see. Could you cover Sonosite Philips ultrasounds? Sonosite is an interesting company, and I'm learning some new stuff about Sonosite. You guys, Sonosite ultrasounds are very compact units. I would venture to say that they're leading the industry when it comes to making ultrasound technology smaller and more portable. Sonosite is a crazy company. Maybe if I had some broken units that weren't in my hospital, I could tear them apart and get you guys some solutions. Because a lot of stuff on sinusites, we have to ship them out. And I think it's a very sad thing that we have to do that, because sometimes it's just like a software problem. And for me, just, you know, capturing an image off of a functioning unit and deploying that image on the unit that's now messed up would probably solve some of those problems. And I've been working on that with other devices using, because a lot of them have solid state hard drives now. So you have to take that unit out and you have to make a duplicate, an image of it, and then you take the bad one and you move the image to it. So I've been doing a lot of that on other different types of equipment. Sinusite might be a good one to try if you have some time. Maybe in-depth video about limb. Bjorn, did you see my video on limb that I already have? I'm very curious because I did a video about line isolation monitors. Man, it was one of my first videos I ever created. And it's also probably my most popular. I mean, it's got thousands of views. And that one, I have a new line isolation monitor tester, okay? And what's really cool is I wish I could get a limb module like the analyzer. And what the limb module does is it actually measures the amount of current that you've got going on your ground circuit. So anyway, I have two brand new line isolation monitor testers. It's the craziest thing. So I would love to do a video on those because these things are just sitting above my desk. Nobody else that I know of at my hospital knows how to use these things. They're made by a company called Bender, and they are a very special device. And you can actually control the milliamps worth of leakage, and you can see like how much voltage is on each of your L1 and L2. Very cool device, very specialized. And since not so many people have them, not so many people know how to use them, I would love to do a video to show you guys how it tests the system, because we induce a certain amount of leakage into the circuit, and then we go to the line isolation monitor panel and you read to see how much leakage you have over there. So you have a calibrated device that creates a calibrated amount of leakage, let's say 4 milliamps. Then I should see 4 over on my line isolation panel. If you don't, well, then your limb is bad or it needs to be recalibrated. So let's see. Matt Miller. Hey, Matt, is this the same Matt that's over in South Carolina? Is it the same Matt Miller? Be very curious if it is. Matt is saying he's curious how many people test limbs in areas like ICU, CCU with patients in the rooms. It isn't. All right, well, it isn't. Okay, Matt, I worked with a Matt Miller who's a biomed out there in South Carolina, and I'm just curious. Good dude, and he's a very hard worker. So just curious. I'm gonna show you. I'm gonna do that video. So once I find an open operating room that I can go in and record, because my hospital's really sketchy about me recording videos, I would love to find a place that has a good limb panel, maybe an old one and a new one, so you guys can see the difference. And take this new analyzer and show you all the dials, all the functionality. That would be a very cool video. I think that's an excellent idea, Matt. And I'm going to run it through and show you guys what a limb does, why we have it, and give an update, because the last video I did was years ago, man. It was like 2.5 years ago. Anyway, have I worked on anesthesia machines? If so, what are some common issues that tend to have on Draeger and Datex? Okay. Well, I'll tell you for a fact that the Draeger machine, one of the common problems that I've had is the flow valves, or the flow meters more so. So the flow meters, they use 2 wires, and they have a what the hell would you call that? Is it an H bridge? Anyway, they have 2 wires, and it takes the resistance of one wire versus the resistance of the other wire, and it uses dilution, thermal dilution. So as there's the flow through the venturi, because it squeezes down, you have a tube, that's your flow meter, and it squeezes down the middle, and that increases the speed of the air. And based on the resistance of those wires, it can tell you the flow rate going through that tube. So what I have is I have seen where nurses take their suction line, they'll fold it over like this, and they shove it in the flow meter like that to hold their suction tube. And I've seen that on GE, because GE has a little flapper valve, and there's ports on each side of the flapper valve. And what happens is there's a pressure difference between those 2 ports. So based on the flow, that flapper will open up more and more, and there's going to be higher pressure on the patient side versus the back side, right? Because with not too much flow, there's going to be a bigger difference between these 2 tubes. And these tubes are connected to pressure transducers. So what happens is, as this flow increases, the pressure in the patient side goes up with a lower flow. And then as the flow goes up, the pressure becomes more even, because the pressure is moving that valve, that flapper. It moves the flapper open more. So both of the pressure transducers start sensing the same or closer to the same value. So that's how they measure the flow in GE anesthesias. Very crazy, but that would be an excellent video too, is a graphical explanation of flow valves in anesthesia. I would love to tear an anesthesia machine right down and show you guys all the stuff inside it. But I think what we have to do is we have to tackle it piece by piece. Like your vent engine, one of them uses bellows, one of them uses a piston. Some of them use a turbine engine, like a turbine blower. So as technology evolves, I think we have to explore anesthesia machines based on the technology that each of the different ones use, instead of just saying, hey, this is an anesthesia machine, this is what it does. I think everybody kind of knows what an anesthesia machine does, but the technology is so different. Take, for instance, a Draeger, a new one with the turbine engine, versus the old one, which actually used a physical piston with a large rubber sock, and it would push on this rubber sock, and that's what would create your air, your pressure. So I think that's how I should do that, is tackle the anesthesia machines based on the technology. So we can go into the computer systems. The computer systems on anesthesia machines are so different between the different ones. We can go back to like the GE Estiva units, which has like a monochrome display, and how they upgraded it with an EEPROM. They have a different EEPROM that's got different software, which allows them to have pressure modes and stuff, whereas before they didn't have any of that. Versus now, like the Draegers are so crazy, like all the different touchscreen menus. So I could have a whole giant series of videos just on anesthesia machines alone, because there are so many cool aspects of them. And I myself am trained on GE Avance CS2 anesthesia machines. My whole entire career, I have tried to avoid ventilators and anesthesia machines. And the reason being is because if you are good at something, you now own it. All right. And I do not want to do ventilators. I do not want to do anesthesia machines, because when do you think anesthesia machines are done? Not in the middle of the day, that's for damn sure, because anesthesia machines are done at night and on weekends, in the middle of the night on weekends. And the reason they do that is because during the day they're on patients, they're being used. Surgeries, whenever the doctors want to do their procedures, which is usually the middle of the day, that's when they do them. And they're not going to shut down a room because you need to PM, an anesthesia machine. So I have tried my whole career not to do anesthesia machines, and you know, I specialize in other stuff, you know, stuff that a lot of people don't like to do or that they can't do. But I do know about anesthesia machines, and I know a lot about them because I have worked on everything from the Apollos, what the Narcomeds 6400s, the Narcomed M's, a whole bunch of them, man. So let me compile like a list of things I'd like to talk about, and I'll get back with you guys. I think that would be an excellent series of videos, guys. And I'm going to actually write that down because I will forget this shit like as soon as I get off of this. If you guys don't imagine, I've got a list of, this is my book full of stuff that I talk about on this channel. And like this is a page on bispectral index, BIS, ultrasonic detect sensors, man, RF tracking. I just, I write it down. All right, let me get a pen because I need to write some of this stuff down. And of course I'm not that organized. Why would I be? All right. Joke's on me. I have a severe problem with flat spacing pens. Like either you stick it behind your ear while you're working and then you forget where you put it, or I'll answer the phone or something and I'll set it down. So anyway, let's see. Operating room tables. You know, I've had several requests for operating room tables, and I would love to do a better video on that. And I think the best way to do that would be to go with a vendor. I've got some excellent vendors up by Woodlands and Surgequip. They actually have a proper surgical table service area where they have them in all different stages of complete rebuilds. And I would love to show it, because if I were to do it, it'd be, in an open room, but probably not the best way, most professional way to present it to you guys. I think that'd be an excellent idea to contact Surgequip and see how they do it. They've already offered a couple times for me to come on up there, so I think maybe I'll take them up on it. Break down the components of the tables. There's a major difference between surgical tables. Now, a lot of people would think, oh, they're all just hydraulic. No, they're not. And in fact, a lot of the newer ones, like Trump tables, they use linear actuators, which is basically, if you can imagine a screw that has got a stepper motor that drives it. So the stepper motor has a nut that is actually your moving piece. And then in the middle of that nut is a threaded rod, and the motor will thread the nut. It'll rotate it, and meanwhile that makes the screw go in and out, which extends the actuator or brings it in. Cool thing about those is they actually know their position, because a lot of them are servo motors. So it keeps a feedback on if there's an overcurrent. Let's say the patient's too heavy. Let's say that there's an obstruction, so the table comes up and it hits something. All of a sudden the motor sees like a heavy current load, and it cuts the power, gives you an error code. There's a lot of cool stuff with those. Whereas a hydraulic table, they don't give a shit. Hydraulic tables, they will just keep pumping the hydraulic fluid until something breaks. And Skytron's got like diverter valves and stuff in them to prevent that from happening. But some tables will just keep on going until something breaks. And that's cool because they're very strong and they can handle very heavy patients. But it is what it is. Anyway, guys, I am gonna let y'all go. 2 hours and 5 minutes. Y'all been listening to me. That's a long time. I'm gonna go in and write these things down and start doing some research, because I want to try and bring you guys these videos very soon. Okay. Thanks again for watching, everyone.